Hello students, today in this video we'll be understanding one more topic from corrosion and metal finishing module 2. In the previous videos we were discussing some topics related to corrosion where we understood what is corrosion, then how exactly corrosion takes place, electrochemical theory behind corrosion, then types of corrosion. In this video we will understand factors affecting the rate of corrosion. Once again student, this is a very important 5 marks question. So one by one we'll see which are the different factors which affect the rate of corrosion. There are numerous factors which affect the rate of corrosion, but in this video I have chosen only the factors given in your syllabus. So first is ratio of anodic to cathodic area. Second factor you have to study is nature of corrosion product. Next is nature of medium. These three important factors which affect the rate of corrosion you need to study. Once again, in the third, that is nature of medium, you have to study pH of the medium, temperature of the medium, conductivity of the medium. How pH, temperature and conductivity of the medium affect the rate of corrosion, we will understand. So one by one, let us first begin with ratio of anodic to cathodic area. I hope students now you are cleared, means you have a clear idea of what we mean by anodic and cathodic area when we are talking about corrosion. In the previous video, that particularly electrochemical theory of corrosion, that video we understood that during corrosion on the surface where corrosion is about to take place, there will be formation of small anodic area and the remaining area becomes cathodic area. One small part where if there are any small hole or small scratch, that part acts as anode and the remaining part acts as cathode. Now this particular factor is mainly depending upon the a ratio of anodic and cathodic areas. Okay, by the theory we already know that there will be small anodic area and large cathodic area. This is a suitable condition for corrosion to take place. So anodic area will be small and cathodic area will be large. That means when the ratio is such where anodic area is small and cathodic area is large, there will be severe corrosion. And if the cathodic area is large, on the reverse, if the cathodic area is large and anodic on the reverse, if cathodic area is small and anodic area is large, then there will not be corrosion or very less corrosion. Okay, we'll see the points. The rate of corrosion is greatly influenced by the relative sizes of anodic and cathodic area. If the metal has smaller anodic area compared to large cathodic area, intense corrosion takes place at anode. Now why this happens? Okay, we'll see that. Because all the electrons liberated at small anodic area are rapidly consumed by the large cathodic area. What do you mean by this? We already know that in the small anodic area, the portion of the surface where, which acts as anode, the oxidation reaction takes place. Metal undergoes oxidation there. There will be formation of electrons as well as metal ion. These migrate towards the cathodic area where already there will be reduced species and more species will be ready to get reduced. Try to understand the concept here, students. At anode, electrons are liberated. Those electrons are consumed by species present at cathodic area and undergoes reduction. Metal ion is oxidized species and which will be present at anode, and at cathode there will be reduced species. Both will combine with one another and there will be formation of corrosion product. Try to understand, student, here. At anode, as the number of electron production increases, more and more corrosion products forms. That means when the anodic area is very small and the liberation of electron will be little, then what happens? Because the cathodic area will be large, large number of species will try to undergo reduction. So demand of electron becomes more. So in that manner, more and more corrosion takes place. On the other hand, if the cathode is smaller, consumption of electron will be slower. You imagine anodic area is large, so large number of electrons will be there, but the species which undergoes reduction will be very small, so more and more electron production will not take place, so less corrosion or speed of corrosion decreases. I hope this is clear now. When the anodic area is small and cathodic area is large, severe corrosion. On the reverse hand, when the cathodic area is small, anodic area is large, less corrosion or rate of corrosion decreases. Okay, we'll understand this concept by taking example. Okay, when tin metal is coated on iron in such a way that some pinhole are left, results in small anodic area. What do you mean by this? There is iron slab on which there is coating of tin. Tin is cathodic to iron, means it is less reactive as compared to iron. But while giving a coat, if there is small hole on the surface in the coating, if there is small hole, then that particular hole portion acts as anodic portion. That means the iron will be exposed to moist air and all. So small anodic area, large cathodic area, there will be severe corrosion. One more example, if instead of tin, if zinc coating is there, zinc is more anodic as compared to our iron. Zinc is coated on iron, then zinc is more reactive as compared to iron. If there is hole, then which will not affect the rate of corrosion. Why? Because zinc becomes here large anodic area and that small hole on iron becomes small cathodic area. Okay, this picture will give you a clear idea. As you can see here, two diagrams are there. Here Fe anode, Fe acts as anode in one case. There will be coating of tin on surface of it, and if there is any small hole, in this situation, this small hole acts as anodic area, small anodic area, and this remaining portion of tin becomes large cathodic area. So there will be severe corrosion, rapid corrosion at small cathodic area takes place. On the same, on the other hand, similar diagram where if on the Fe, if zinc coating is given, zinc is anodic to Fe. That means it is more active than compared to Fe, which is zinc is more active as compared to Fe. That small hole will not affect. Why? Because cathodic area will be large and anodic area will be small, so there will not be corrosion as much. If any one among Fe and zinc will undergo corrosion, that will be zinc. In this manner, ratio of anodic and cathodic area will affect the rate of corrosion. I hope it is clear. So we'll move on to next factor, which is nature of corrosion product. What do you mean by this? Nature of corrosion product. Whatever type of metal it be, there will be a corrosion product formed after corrosion. Okay, so in the previous video we saw the rusting of iron, in which first iron hydroxide will be formed. Then when it is exposed to more and more oxygen, iron oxide, then ferric oxide, which is rust, will be formed. So step by step reaction it will be. So whatever that first product formed, which was iron hydroxide, it will act as protective layer on the surface at the beginning, but when it is exposed to more and more moist temperature, moist atmosphere, temperature, different entities of the medium, then it undergoes further corrosion. Now here this point also, this particular factor is also depending on that. Okay, the corrosion product is usually the layer formed on metal surface. It determines the corrosion rate. If the layer formed is highly insoluble and non-porous with low electronic conductivity, then the layer formed prevents further corrosion. What do you mean by this? If whatever initial corrosion product formed is non-porous, or if it is highly insoluble, then it will form a protective layer. It acts as a protective layer and it resists further corrosion. How? The thin layer formed acts as barrier between fresh metal surface and the corrosive environment. So it's something, it's like nothing but a coating. Initial whatever corrosion product formed gives a coating on the metal surface, hence it resists the attack of further oxygen or moisture, and in this manner it prevents the corrosion. When? Only if the corrosion product is of non-porous or highly insoluble or low electronic conductivity property. If the nature of the product formed is such, then it resists the further corrosion. But on the other hand, if the corrosion product formed is soluble, if it is non-soluble, non-uniform or porous, then layer formed cannot control corrosion. If whatever product formed is porous in nature, or if it is non-uniform in nature, then what happens? The layer detaches off or whatever, and then severe corrosion takes place. Okay, metals like aluminum, chromium, titanium, etc. forms thin oxide layers in corrosive environment on their surface and becomes passive to corrosion. On the other hand, metals like Fe, zinc fails to do so. You might have observed this, students. If you have any iron article at your homes, so initially there will be formation of light brown color layer, then slowly severe corrosion takes place. But just observe it at your places. If you have any copper utensils at your home, as soon as when you brought it, it will be very shiny in nature and all, but slowly its shine fades, but you will not find any corrosion product. In the case of severe corrosion of copper, you may get a bluish color layer on it, but severe corrosion does not take place. Why? Because whatever corrosion product formed, in that case, in copper's case, it protects the metal from further corrosion. So this was nature of corrosion product. So we will move on to the last factor, which is nature of medium. Now what do you mean by nature of medium? When the metal is exposed to surrounding environment, its pH, conductivity, humidity, so many factors come. So here you have to study pH first. What if the pH is low? What if the pH is high? What if the pH is moderate? So such study here. Generally, acidic medium is more corrosive than alkaline and neutral medium. However, some metals like aluminum, zinc, etc. undergoes fast corrosion in highly alkaline medium. Always, students, remember, when the medium is towards lower pH range, when the pH is low, that is when it is acidic, then what happens? More and more severe corrosion takes place along with hydrogen gas liberation. So when the pH is neutral, in the neutral water also there will be corrosion, but when the pH becomes higher, basic, then corrosion rate decreases slowly. Why? Because when it becomes basic or towards alkaline medium, what happens? The instead of oxide and all, hydroxide layer will be formed, which will act as barrier for the further corrosion. This was effect of pH on rate of corrosion. Then temperature. With the increase in temperature, the reaction as well as diffusion rate increases. Thereby, corrosion rate is generally enhanced. As the temperature increases in any reaction, the activity level of the reaction also increases. So naturally the corrosion, it is also a kind of reaction the rate of reaction increases. With the increase in temperature, always our corrosion increases. In the case of corrosion resistance, in some metals which are passive in nature, they resist corrosion at ordinary temperature or normal temperature, but at higher temperature they undergo corrosion. So this was effect of corrosion. Then last, conductivity of the medium. If the medium is conducting nature, uh, it will act as electrolyte and increases the rate of corrosion. The rate of corrosion is directly proportional to the medium's conductance. If the conductivity of the medium is high, then the rate of corrosion will be high. For example, Fe undergoes corrosion faster in clay than sandy soil. So clay then sandy soil. So many different minerals will be there in clay, which once again increases the conductivity. So conductivity is directly related to rate of corrosion. So this was it, students. I hope the factors which affect the rate of corrosion is clear to you now. Thank you.